Alright. I actually just erased what I just recorded, so I'm going to walk you through these first 2 pages of notes. Alright. This activity is done for you. I mean, it's just kind of pulling it out for you and doing all the work for you. So I'm going to explain it. It first says take this triangle ABC and then draw a point somewhere on the segment E. And then if you copy angle B up here, right, if you can copy this angle to E, meaning these two are the same, and draw across, you can add point F, which is what that says. Then it says, hey, you know what? Are these parallel? Well, they are, because these angles are the same, and the converse of corresponding angles, not corresponding angles, that says if lines are parallel, the angles are congruent. The converse says, hey, if the angles are congruent, the lines must be parallel. And that's how you prove that those two are parallel, right? And then they want us to make a comparison. And the comparison is really the whole lesson. They're saying, hey, what if I compared the top half as a fraction, AE, over the bottom half, EB, there's our fraction, this portion over this portion, all right down here, to the other side, AF and FC. And what we do is we find out they are equal. We could measure it. Let's say I had 3/4. This side could be 6/8. Obviously it's not. I'm making up arbitrary numbers. But they will always be equal. Alright? So, how do we know the triangles are similar? Because we had angle, angle. Right? Angle, angle. They share angle A. And what do we know about those ratios? They're proportional. Alright, we're going to hit the other side really quick. Alright, here's the actual note. It gives it to you. It says, hey, if you got this triangle and you draw a line that's parallel to the bottom, the two top halves, right, over the two bottom halves are proportional. So AE over EB, AE over EB is the same as AF over FC. And literally, this is almost the entire lesson right here. I'm going to use it to prove this. Alright, I'm going to use this up here to prove this. And I think I'm going to change it even. Alright, so here we go. Alright, so it gives us this figure, right? Tells us these are parallel. So the first thing I say is I say EF is parallel to BC. Right? Given. EF and BC, parallel, given. And then you can do the corresponding angles, like 1/2 is congruent to 3/4, right? And then you can say the triangles are similar, which are what? BAC, that's the big triangle, is similar to triangle EAB, AB, by angle, angle. And I'm going to jump right to the proportionality theorem, because once we prove the triangles are similar, I have the rest of the proof down here. So let's talk about it. So, look, if they're similar, this whole side here, right, the entire side over AE, those are just, literally that's big triangle over little triangle. This side is to this side as this side is to this side. Alright? That's what we've been doing with similar triangles. Well, then we can break it up, right? We could say, hey, you know what? Let's go ahead and add these little triangles to both sides, right? So if I add 1 AE over AE, I add that, and then I add 1 over here, right, which is AF over AF. These are just adding 1 to both sides. Alright? We've changed AC, right? We've changed AC to AF and AC, right? So if we do that, we can then say, hey, you know what? Let us go ahead and change this into 1. AE over AE is just 1. AF over AF is just 1. And we have this new equation, right? If I subtract 1 from both sides, right, subtract 1 from both sides, I get EB over AE, AC over AF, and then I just flip them over and we have our rule. So all of that was to prove this. The top half over the bottom half, and they're not really halves, I should say portion, is similar or equal to the top portion over the bottom portion. So again, if I use those numbers, it would almost be like this was my division bar. 3/6 is equal to 4/8. They sure are. They're both 1/2. All right, I'm going to pause. I'm going to show you how this works and talk to you soon.